I hope everyone's doing well. I am Mr. Ish. Thank you for joining me for this video, which serves only for educational purposes. What are we looking at here today? 2,4,6-trinitrotoluene or 2-methyl-1,3,5-trinitrobenzene based on how you number this compound. Either way, we are looking at TNT. Look right here at the very first designation. Trinitrotoluene, where your parent compound is a toluene compound where a methyl group is attached to a benzene ring, which you can classify as that. And if that is the case, then you're looking here at carbon number 1, then 2, then 3, then 4, then 5, and 6, in which case the nitro group, which is your NO2 group, hence the trinitro, because there are 3 nitro groups are attached to carbon 2, carbon 4, and carbon 6, and this right here would be the structure either way, but in terms of numbering, it represents compound number 1. When you recognize the second one, it is represented as here, the parent compound being benzene. Now in this particular case, the nitro group takes the position of carbon number 1. Here's 2, here's 3, here's 4, here's 5, and 6. The methyl group attaches on carbon number 2. Either way, the compound is still the same. If you were to rotate it, you'll see it to be exactly the same. Your nitro groups are on 1, 3, and 5. 1, 3, and 5. And either way, you're looking at TNT, TNT. Just do a little bit of a rotation over here. In this direction, it will look exactly the same. You can abbreviate both of these as TNT. What is the purpose of this video? We'll show you how to synthesize this in a generalized manner. Before we start, it has to be decided, are we starting here with the parent compound toluene, or are we starting with the parent compound just benzene? And this right here will be our parent compound, the benzene. So you're starting here with a benzene. Now consider this, if you have a benzene ring and you have a compound over here, a compound can either activate the ring or it can deactivate the ring based on if this right here generally is electron donating or electron withdrawing. If it's an electron donating group, it will donate electrons to the ring, and then it will direct compounds to be added either in the ortho position or in the para position right here. What does it mean? Based on this reference compound, you're going to add something 1 carbon away, or you're going to add something 1, 2, 3 carbons away, and that would be para. When a compound is added 1 carbon away from your activating or deactivating compound, it's in ortho position. If it's 3 carbons away, it's in a para position. Likewise, if you have a compound over here, which is your reference compound, and then you are adding a compound 2 carbons away, then you are adding here an item here in the meta position. When you look over here at 2 different items being added to the benzene, one of which is the methyl group and the other one is a nitro group, this right here is an ortho or a para director. It will either add compounds in ortho or in a para, and this right here is meta director because it will add compounds to the benzene in a meta position, meaning 2 carbons away. So you want to be starting your synthesis with an item that will activate your benzene and make it more reactive versus something which will hinder synthesis. If you start your benzene and add your methyl group, it will activate everything for the further reactions that will follow. Your generalized reaction sequence is this. You're starting here with the benzene, and I'm always representing as this, and you know it to look at something like this. The only problem is, by means of a resonance structure, it can also look something like this. And there will be an intermediate structure in between which will represent the reality of what it is, and you can represent it like this. Like that. So hence I'm representing benzene like that versus something like this. So keep that in mind as well. Your first item to do is to add a ortho para directing compound, and that's your methyl group. You'll do it by means of a methyl chloride. This is a compound easily available, aluminum chloride. You are looking here at something which will be a Friedel-Crafts alkylation reaction. What does this mean, alkylation? It means you're alkylating. You're adding an alkyl group. What's an alkyl group? It's something like a methyl group, but it's also like an R group. Any hydrocarbon can be represented by this R, and any R group being added to your benzene is called an alkyl group being added to your benzene by means of the Friedel-Crafts alkylation. You're looking here at CH3Cl, AlCl3. It's a Lewis acid, and you'll add to your benzene ring very easily as here, and giving you what your compound will now become toluene. Starting here from benzene, now you're at toluene, and that's where we are. you know this to be a ortho-para directing compound because it activates the ring by means of induction and electron donation to your ring. What you have to do now is somehow add 3 nitro groups to generate the trinitro. That's what will direct what remains. For the remainder of sequences, you will see something like this. You'll add HNO3, H2SO4. You're adding here a nitric acid in the presence of sulfuric acid, and because this right here is an ortho-para directing, you're gonna see a para directing addition right over here. So you'll see CH3, and then you'll have your benzene ring right here, and then the first nitro group will add right here in the para position, 1, 2, 3 carbons away. Now what you will do is repeat the reaction again once more with another round of HNO3, H2SO4. Obviously, in between each of these steps, you're doing your isolation, purification, all of that. We're not discussing that, but that's industrial process. When you add it over here, now you have a competition between 2 items, one of which is a methyl group and one of which is a nitro group. What directs it? You know here you have an ortho-para director, and I'll mark it right here. Here you have a meta director. Which one of these is an activating? It's this. Which one is deactivating? Is this. Which one would really win in a competition? It would be a methyl group. It would win because it activates the ring and it directs based on its presence. But the benefit here is in this tug of war, both of them win. This wants to put everything in a meta position. This wants to put an ortho or a para. So you will see that in the ortho position or in the meta position, your next nitro group will attach right over here. And let me clarify that for you in terms of clearer handwriting. And you will see the nitro group to add over here. And in another round, HNO3 and H2SO4, again the competition is between an ortho-para directing and a meta directing, and you will again see it will add right over here naturally in the only available position which benefits both compounds, the nitro and CH3. And if you look at it from this position, you're adding meta to that. So this right here is a natural outcome of this last step, giving you your trinitrotoluene, or either of these names. As you can see, if this is your parent compound toluene, then you're looking here at 2,4,6 trinitrotoluene. If your parent compound is a benzene, you're looking at a 2-methyl 1,3,5 trinitrobenzene. Either way, it's still TNT, and the synthesis is fairly easy. And that brings us to the end of this video. Thank you.